Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, does the car understand the world? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week's episode is all about self-driving cars and how the latest advances in artificial intelligence can help them drive and perceive the world more like humans. But first, I'd like to remind you that you can send in your questions for my future guests, either by contacting us on social media. We're at Robot Talk Pod on all the socials, or you can submit questions via our website by going to robottalk.org. And don't forget to enter our competition for a chance to win your very own Robot Talk t-shirt. For more information about the competition and how to enter, check out robottalk.org. So, with all that said, let's get on with this week's interview. I recently had a very interesting chat with Vassia Simaiaki from Wayve, all about computer vision, artificial intelligence, and self-driving cars. You might notice a bit of background noise during this interview. That's because clearly the Wayve office is a hub of activity. So I'm really sorry that the audio quality isn't quite as good as usual, but it's a great interview and I think you'll really enjoy it. This week, I'm chatting to Vassia Simaiaki, Head of AI, Vision and Graphics at Wayve, a London-based company using AI to pioneer a next-generation approach to self-driving. Hi Vassia, great to have you on Robot Talk.
Hi, excited to be here.
So, to get us started, can you tell me a little bit about the current autonomous driving capabilities of Wayve's cars?
Yeah, sure. So Wayve has an end-to-end approach when it comes to driving. So we are pioneering developing embodied AI to power driving automation. So our approach of AV.0 uses a data-driven end-to-end AI system to allow technology to adapt and learn in diverse environments and vehicle types. Okay. We are able to drive in London with a safety operator driverlessly, as this is what we need to do from a safety standpoint. And we're working towards an L2 plus driving experience.
What do you mean by end-to-end in this context?
So I'll touch first on how it's different to AV.1 approach, which is not end-to-end. So in a more traditional approach, we will have a chain of tasks. So we'll have a model which is trying to decompose the scene around and be like, okay, there's a traffic light. And then you will have a different heuristic to say, okay, there's a traffic light and it's red, therefore you should stop. Our approach is end-to-end, which means we use our data to understand the world around us and try to learn how a human would learn. So we get all the data from around the world and the actions that the human drivers do. We put that all in a big neural network, and then that figures out how to drive by mimicking how we drive. So instead of having a rule-based approach and different networks that provide different inputs to that, we have this end-to-end approach where we use data around us and try to learn how human drivers drive and imitate that. So that then would allow us to generalize in different conditions, different environments, and we require less hardware inputs as well.
Okay, yeah, that's really interesting because people often have spoken to me about how much better humans are at driving just because of that ability to generalize, I think, to situations we haven't seen before.
Yeah, and the humans have this understanding of the world, general understanding of the world, which is not specific to driving. So we also would like to think that with our approach, if you see an unseen new scenario, our models will still be able to react to it in the correct way, like a human would do. We haven't seen all the scenarios, but we haven't good enough understanding of the world that we can derive what's happening around us and make the right decision.
Yeah. And so you're specifically working on computer vision and novel view synthesis for autonomous vehicles. So what exactly is view synthesis, and what are the biggest challenges in this task?
Yeah. So view synthesis is when we're trying to recreate a 3D world from images. So in the driverless scenario is we have cameras around the car which record as they drive through a road or a scenario. So then we're able to take these images and reconstruct that scene. So from 2D images from different viewpoints around the car, we're able to take them and have a small neural network that is then able to reconstruct that scene. The challenge there is that we want to be able to reconstruct also the things that we didn't see or the car went too fast and we don't have a good representation of. So humans are really good at doing that. So if you see part of a car, you're kind of able to imagine the other part. So that's exactly what we're trying to do, to generalize and be like, okay, you've seen this part of the car, now figure out what the other part would look like. So if you're then replaying the same scene with exactly the same parameters, it looks usually quite good, but the main challenge is how do you reconstruct the things that you haven't fully seen or you don't have enough images or information on. And the additional challenge with our problem is the moving objects. So we call them dynamic agents. But as you can imagine, again, everything that's moving, it's changing really fast. Our car is moving, the other cars are moving, and that creates challenges when we're trying to reconstruct the scene. So my team is focusing on that and trying to create realistic scenarios with high fidelity, and specifically focusing on these dynamic objects, so objects that are moving, which is the main challenge for our case.
Yeah, I mean, because we do it so, implicitly, it's kind of, it doesn't sound that complicated until you actually start to imagine how you would do it. And just thinking back to like the hazard perception task in the driving test, and how many things can be going on in one scene at any one time. And obviously, even those are kind of simplified versions of reality. So yeah, I can see that this is not a small challenge to try and tackle.
Yeah, for sure. But it has also massive benefits for us. So we can use this in different ways. You can use it to replay what happened in the real world in a closed loop and have this data-driven simulator to do that. That can allow you to debug your model, understand what happened in a specific scenario. You can alter the scenario potentially, so you can remove objects or add them, which is another challenge and a different capability. But this is also a way where you can prove safety and show that these are the scenarios we can react to, and this is how this is working. So it allows us to really create this path towards this intelligence platform that can help us generalize and handle new scenarios and be able to prove it.
And so, you talked about integrating this data from different cameras. Have you got other kinds of sensors? I mean, I know LiDAR is quite commonly used. Is that something that you're also integrating into it?
No, I think that's another benefit of our approach and the end-to-end driving, that we don't rely on expensive hardware or other inputs to make our models work. Similarly, we don't need a very detailed map of the routes we're going through, so we don't rely on HD maps that other almost self-driving vehicles would rely on. So the inputs are mainly the camera sensors, but of course, as we move forward, as required, we may add other ones. But again, one of our propositions is that we can do this as a human would do with less expensive hardware, which can help us on this generalization, which is twofold. One is that more technically wise, that you can generalize different scenarios, different routes, different urban situations, and more commercial as well, that you're able to take this technology integrate with, again, different driving, different vehicles. Like we have vans, we have cars, which have different configurations easily. And also, again, that you can take them in different environments and will still work. And we kind of have an example of this with one of our partnerships with Asda, where we're able to kind of extend how many residents Asda can expand to deliver groceries without doing any additional work. So they were able to go from 200,000 residents to 400,000 residents with new routes without us having to do any explicit work to do that.
Wow. Yeah. I mean, I've seen some of the videos of the Wayve cars out on the roads, and it's already seems really impressive what you're achieving. So I can only imagine how much better it will get as you keep developing and improving these algorithms.
Yeah, that's what we're hoping for.
Previously, some of my guests on the podcast have been like academic researchers who have been doing various aspects of autonomous driving for different applications. And they've kind of described to me this really difficult task of gathering enough real-world data to train AI algorithms on. And the classic example they give of kind of when this goes wrong is the plastic bag in the road, because it's all these different shapes. It's really hard for the computer to understand. So I know you've talked about this generalizability and being able to deal with situations that are novel. How does that hold up to the plastic bag scenario, or similar things that may be kind of really difficult to make sense of?
Yeah, definitely. Data and generalization is one of the main difficult problems to solve. And even without these more extreme scenarios, like even if you take any driving scenario, not two of the same will never be exactly the same.
Yeah.
So being able to adapt is very important. I think we're building different things to be able to address this. So if we look at last year, developing Gaia and the world modeling capabilities is one of those where we want to have the ability to understand, back to that point, to understand the world, and also with Gaia be able to generate new scenarios and new situations and control for them. That can allow us to have more data, more diverse data, and specific scenarios that we can input to our system. And also with some of this work on the 3D reconstruction, it's more control, it's things that we've already seen, but being able to add, remove, adjust, augment data, you can create these a lot higher scale synthetic data that you can add to your data that you train your model, your driving model. So our idea is with combining different methods and different sources of data, so real data, synthetic data, we will be able to generalize, and you won't need to explicitly model all these specific examples. So we prepare our system to handle basically the long tail of these driving scenarios, and that's one of the benefits of this end-to-end approach, that you don't need to go and hand engineer every single scenario and be like, okay, if this happens, do this.
Yeah.
But again, to the previous point, be able to have this knowledge of the world and be able to generalize. And with these different techniques and capabilities, which are very cutting edge and very new, we are able to create synthetic data that can enable us to do that.
Okay. Yeah, that's really interesting approach to it. And I mean, I've seen you're testing these cars in central London sometimes, which is really, of all the places that you can have to drive, as a human driver, central London is probably one of the most stressful. There's so much going on. There's pedestrians, there's people, crossing the road unexpectedly, and there's a lot going on.
Yeah, for sure. And I think that's also our, again, maybe selling point, that if we can drive in London, you probably can drive anywhere. And then because we have all these complex scenarios, again, it's very hard code all of these things that could happen in London.
Exactly, yeah.
Also, roads are really narrow. You need to maneuver in certain ways, like there's roadworks all the time. So again, that gives us a good challenging problem that we can focus on solving and then generalize to other scenarios.
Mm-hmm. So what are you working on currently, and what's next in your plans for developing the AI and vision capabilities at Wayve?
Yeah, currently our main focus are the dynamic objects and increasing the capabilities of our neural simulator, and then also combining all the capabilities we have in-house, pushing the boundaries even more, creating more breakthroughs to get to a world where synthetic data can be used effectively to train and also test our models effectively. I think, again, the application, one is we always want to improve performance of the driving model itself, but also these tools can help us with safety and trust, where you can, again, show that you can handle the situation in the real world and tweak the scenarios and so that your model will still handle them. So again, our main focus is on the neural simulator and the kind of synthetic data aspect of it.
Mm-hmm. Yeah, I mean, I'm sure that's keeping you very busy. It's really good to hear that. I mean, obviously, safety is such an important aspect, and trust that you mentioned. Like, if we're going to move towards this future where autonomous vehicles become much more commonplace, then it's so important that people can trust them and feel safe and know that they're going to get them safely to their destination.
Yeah, for sure. And we've seen that with other self-driving companies, that this is a main aspect, and hopefully we can also take these learnings and make sure we are able to prove that and engage the public and get to a place where our cars are safer than what they are today and also what they can be.
Absolutely, yeah. I mean, I will be watching Wayve's progress with interest over the next few years to see, what you guys come up with next. Vassia, it's been lovely speaking to you today. I've been talking to Vassia Simaiaki, Head of AI, Vision and Graphics at Wayve. Thank you.
Thank you.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast and leave a review to let us know what you think. And make sure you check out our social media channels to see a photo of the Wayve self-driving car on the streets of London. We're at Robot Talk Pod on all the socials. Next week, I'm speaking to Chang Liu from Extend Robotics, all about teleoperation, virtual reality, and software. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.